Hi there. So this is the last video for the 11s project. So first of all, I want to clear up something I did yesterday, which I apologize for. I'll blame it on this flu. I referred to the class, that the abstract class, as the subclass. It's in fact the superclass, right? The classes that derive from it are the subclasses. They're in my head, I sometimes make this error. I've done it more than once because the subclass has more functionality. So when something has more functionality, you tend to think like super above, right? But it's not. It's okay. So always the first class, the one that is extended, is the superclass. The class that extends is the subclass. Got it? Good. Superclass, subclass. All right. So in this video, I'm going to go over a few things. We'll start with a 13s game, which illustrates, without changing anything in the superclass board, we can make a new solitaire game called 13s, in which the cards are valued 11 through 12. 11 is Jack, 12 is Queen, and King is 0. And you either get two cards that add up to 13, or you get a king, right, which is essentially 0. They could have done 13 there. They choose to do 0. All right. So all that's needed here, the small changes in this. In 11s, these are 0, 0, 0, because none of the base cards have values. So that little change. Overriding from the superclass in this subclass is legal. Overriding another play is possible from the superclass. And then find a pair of 13s. This is just a nested loop thing. Won't go through it in detail. We've done that before. This is find king. This is a simple loop that's just going through and checking each index position of the array to see if it's a king. And then this is something we'll get to in a bit. This is other code down here. This is for if the computer is going to play. They added basically versions of the two methods I just went over, except these methods actually do the replacing that's done by the user with the mouse in the GUI version. Okay, so subclass, superclass. Now, let's go back to 11's board for a minute. I did want to go over this, review this, right? So what is this Java util list thing, right? So it's always imported in these methods. And then these lists are declared, not so much, where do we declare it? Here. We declare a list of integer called c-indexes. But yet, these lists are always either array lists, right? Eventually, in these cases, they're array lists. So why even bother with this listing, right? Well, and what is list anyway? So let's just take a look at that. Let's review. So just make sure that's within our bounds. So there's from the Java class documentations, there's the interface list. So it's an interface. Now remember what an interface is? An interface is basically a list of methods that any class that implements the list must write complete methods for. So you'll notice that array list is one here. Oops. But also linked list and other kinds of lists. Role unresolved list. Wow, that sounds cool. Role list, attribute list, abstract sequential list. Cool. vector stack, different kinds of lists. They're not in the curriculum for this course. But any data structure that's declared as a list type could actually hold a reference to an object of any of these types. So if later on we decided, and I've said this before, like linked list is something that used to be covered in the AP, if we wanted to change the list type from array list to linked list, then very few changes, just one or two, would be needed in our code. And because both linked list and array list implement all of these methods of the interface. Sorry, right? So all of these methods are in. If you go and look up array list, the methods of array list, you'll find all of fully defined methods for all of these things. And I can do it. I've done it. Here's the class array list, and look, here are these all the same methods, right? And those are not abstract methods. Those are full methods. Linked list, same thing. Here are all the methods. Whoops, right? That the interface list says must be defined by any class that implements list. Right? Cool. All right, final thing for this video. So an 11s simulation would run the 11s board over and over again. So to do that, added here are, just the way in the 13s game, are some new methods. Play if possible, which will return play pair sum if possible, or play Jack, Queen, King if possible, right? So play pair sum will actually pull out the two cards, right? The way I did it, similar to the way I did it in my first, when I went over my version of 11s, right? So the computer's playing the game. It's not the user clicking on the user interface elements, right? So if that's true, right, what happens to the rest of the statement? This is a review. This is called short circuiting. Will this condition even be checked if this is an OR and we get a true here? The answer is no, right? As soon as Java sees that this total Boolean expression must be true at this point, because if one is true, right, then both are true. I mean, one is true, then the whole expression is true, no matter what the value of this, whether it's false, it doesn't matter because it's an OR. Now, similar with if this were AND, right, and if this were false, would it check this second condition? No, because if this is and it's a false here, then it knows that the whole expression is going to evaluate to false, so it's done, right? So this is called short circuiting, and you can actually use this, right? Because there's situations where over here you might have an array index, right, or an array list index that could be out of bounds, right? But if over here you check to make sure that it is in bounds, right? You know, some condition that says it's less than the size of the list, then you know that you're never going to accidentally, over on this side, check that index when it's out of bounds, because this false would have prevented the second one from being checked and giving you a runtime error, which you want to avoid. Okay, cool. The rest of these are really, you know, I'm not going to go over them because they're basically stuff that we've already done. They're just code for finding the cards and replacing them, pulling them out and replacing them with new cards, right? And same with the Jack, Queen, King. Okay? If you're interested, I can send you this code. Just send me an email. I'll be happy to send it to you if you want to do that. So we'll finish off with a run of this. But first, let's change the games to play. I have it set at 3. Let's just change. I find that when I was doing testing, about every 5 or 6 games, I would get a winning game of 11s. So let's do 10, and that should give us, I'm guessing, we'll win once within those 10. So we'll compile that and we'll run it and let it go. Twice. Okay, within 10. So that's pretty reasonable. All right, so this weekend, I would be working, if I were you, I would be working on the your review books. If any of you would like additional questions, let me know. I can send you some, both multiple choice and free response. Okay, that's it for now. Thanks.